This video is on section 3.3. We're going to be talking about properties of functions such as whether or not a function is considered to be even or odd, is a function increasing, decreasing, or constant, and where is that taking place? Can we identify local maxima or minima? And then we're going to end up with finding the average rate of change of a function. So a lot to do. Let's just jump right in. If you don't have your book open to page 230, go ahead and grab it now. Just pause the video. You need to be looking at a graph so that we can answer these questions. So go ahead and do that now and then come back. Okay, so looking at the graph that you see there at the bottom of page 230, let's talk about what functions, when it refers to is a function increasing on a particular interval, what is that referring to? So this particular graph, the first question that we're going to answer, number 11, is the function increasing on the interval from -8 to -2? So first of all, this is an interval. All right, this isn't talking about an ordered pair. The interval is from x is -8 to x is -2. Okay, so in other words, think about the point there that you see on the bottom left-hand corner, -8, -4, and then you're moving up to -2, 6. Okay, these are just the x coordinates, so this represents a range along the x-axis. All right, so look at the function and you notice that it's like a positive slope. It's moving upward from left to right. And so the answer to number 11 would be yes, the function is increasing on that interval from x is -8 to x is -2. Okay, using that same line of thinking, let's look at number 13. Is the function increasing on the interval from x is 2 to x is 10? Okay, again, you can't think of this as the ordered pair 2, 10. Let's think, for example, from the point 2, 10, and then look to the right where x is 10. Well, I do agree that it is increasing on the interval from x is 5 to positive infinity, but in the interval from x is 2 to x is 5, in other words, from the point 2, 10 to 5, 0, it's decreasing. All right, so the answer to this would be no, it's not a continual increase in this entire interval. It does increase in part of it, but not the whole interval. So the answer to number 13 is no. All right, so let's just go ahead and list all of the intervals on which this function is increasing. Well, one of them we already said, from -8 to -2. Again, we're going to do this in interval notation, and these represent x coordinates. Notice also that the function is increasing from the origin up to the point 210. So just using the x coordinates, we would say from the interval 0, it's increasing on the interval 0, 2. And if you notice, it's also increasing from x equals 5 and then to positive infinity. Now, it's important to note that we did not use brackets here because we want to know where the function is actually increasing, not where it is a constant. All right, so it's not increasing at -8, it's actually changing directions. At -8, it was decreasing, it hit -8 and then changed direction, and that's what's known as an inflection point. When you get into calculus, we'll talk about that a little bit more. So, at the actual -8, at 0, and at 5, it's not increasing, it's changing direction. It's kind of constant at those numbers. So that's why we don't use brackets. That's an important thing to remember. All right, so number 17, is there a local maximum value at 2? Well, let's talk about local maximums. Those are turning points. Okay, a local maximum occurs when we were increasing. We hit a turning point, a point of inflection, we change directions. You can have more than one. You may do that again with a function. You are increasing, it's like a peak, you get a certain point, and then you go the other direction. So the answer to this, is there a local maximum value at 2? Well, there certainly is, because that represents a turning point from increasing to decreasing. And the value that it's looking for, first of all, we'll say yes. The value is going to be the y coordinate of that turning point. Okay, so at 2, the y coordinate is 10. So when it's asking for a maximum or minimum value, you're going to use just the y coordinate of that ordered pair. Okay, so moving right along, this is number 19. List the numbers at which f has a local maximum. What are the x coordinates of our local maximums? Well, there's 2 of them, 2 turning points that represent local maximums. There's one at -2, 6. Well, this is just asking for the x coordinate. And then there's another one that we just talked about at +2. When it wants the values, now you include the y coordinates. So for -2, that was 6, and for +2, that was 10. All right, so that takes care of that first, some of those first problems related to that pictured graph. All right, now let's move over to number 21, and we've got several things to answer. Some of this is review. Let's go ahead and take care of the intercepts. We have x-intercepts at -2, 0 and +2, 0. And we have a y-intercept at 0, 3. Okay. The next part is the domain and range. So we've been doing some of this. The domain, in other words, looking this way, the x coefficients involved in this graph, numbers along the x-axis, well, it extends from -4 to +4 and all the x's in between. So we'll state it like this: x such that the x values in between -4 and +4. For the range, we're going to look vertically. And if you notice, these range values, the y coordinates, extend from the origin upward to y = 3. So the way we'll state the range is all of the numbers in between 0 and 3, and those are included since we have a solid circle here. These values for x are included because both of these circles are solid. And that takes care of the domain and range. Okay? Okay, so we found the intercepts, we've found the domain and range, and now the next part, letter C, is to identify the intervals on which the function is increasing, decreasing, or constant. And so let's just take increasing. Do you notice that in this area that I'm marking in red, the function is increasing? That's also taking place along this interval. And so the way we identify these intervals is just by using the x coordinates of the ordered pairs in between. So we would say that this function is increasing in the interval -2 to 0. It's also increasing in the interval from x is 2 to x is 4. Okay, and now let's take a look at where it's decreasing. Well, obviously you can probably tell it's decreasing in this interval from -4 to -2. And it's also decreasing in the interval from 0 to 2. And once again, notice that I used parentheses here because at the actual numbers, it's not increasing or decreasing. That's called a turning point or an inflection point. And we want to know just literally where the function is either increasing or decreasing. Okay, so letter D, this is a topic that we haven't addressed yet. Determine whether the function is even, odd, or neither. So let me just give you a way that you can remember that. For a function to be odd, that means it has origin symmetry. Okay, write that out for you. For a function to be even, it has y-axis symmetry. All right, so hopefully you can tell, we've looked at symmetry in the past, you can tell that this particular function has y-axis symmetry, and so we're going to say that it is an even function. Okay, so if you're just looking at the graph and you're trying to tell even or odd, it's easy to remember because think of the O in odd and the O in origin. That might help you keep those straight. All right, that takes care of number 21, so let's do another one of those. This is number 23. So once again, let's just walk through all the parts. Let's find the intercepts. Well, there's only one. We have that y-intercept 0, 1. Okay, let's identify the domain and range. So the domain, we're looking at the numbers along the x-axis that would be involved in this particular graph. This graph goes forever to the left according to the arrow, and it's going to continue going forever up and right. So for the domain, we're going to state it as all real numbers. For the range, this particular range, the values approach the x-axis where y is 0, and then they go up forever from there. So we're going to state the range as all of the y values such that y is greater than 0. Okay, so that takes care of the domain and range, and now let's look at part C, the intervals on which the function is increasing, decreasing, or constant. Well, let's see, it's increasing for values of, as the function gets larger values for x, it's always going to be increasing. So as we approach from negative infinity, as you can tell, coming from left to right, it's always increasing. All right, so the way we can state the interval to represent the function increasing, it's really from negative infinity to positive infinity. And this particular function is never decreasing. You could put no, or there are no intervals on which this particular function is decreasing. By the way, constant would mean just a straight line, and at this point we haven't run into that situation. All right, so now we're ready to state whether the function is even, odd, or neither. Well, again, even would mean it has y-axis symmetry, which is not the case here. Odd would mean it has origin symmetry, also not the case. So there is no symmetry, or it's not either. I guess we would say neither. And that takes care of number 23. Let's do one more like this. This is number 25. Once again, we'll state the intercepts. So we have an intercept here, an x-intercept of negative pi 0. We have the origin 0, 0. And then over here another x-intercept pi 0. All right. And let's see, domain. The x-coordinates would be between negative pi, so we're going to state it as x such that all the values between negative pi and positive pi. And we're going to include those because we have solid circles there on the ends. The range, let's check out the values that would be involved. Basically, this graph stretches along the y-axis from here to here, and so the way we represent that interval, that's between -1 and +1, and we're going to include those because we have solid circles at both of those places. All right, that takes care of domain and range. Let's talk about the intervals where the function is increasing. Well, it's increasing in this interval, and that is from, we'll just identify it this way, increasing from negative pi over 2 to pi over 2. That represents increasing, and it's decreasing at these other two areas, these two intervals, from negative pi to negative pi over 2. That's one interval where the function is decreasing. And then also here from positive pi over 2 to pi. Okay, and now we're going to state whether or not the function is even, odd, or neither. Okay, well again, there is no y-axis symmetry, so it's not going to be even. There is origin symmetry. Hopefully you can see that. We have origin symmetry, so that means this is going to be an odd function. Okay. Let's take a look at this next block of problems. The directions tell us to determine algebraically whether or not a function is even, odd, or neither. We saw how to do it when we're looking at a graph, but how do we do it if we're just looking at a function? Well, notice what I've given you here. If you can substitute negative x in place of x, that's what this is saying, and you get the original function as a result, then you're going to have y-axis symmetry, which means it's going to be an even function. If you substitute negative x and it changes it to the opposite function, the opposite of the original, then you're going to have symmetry with the origin, which means you're going to have an odd function. So let's just do a little test. Let's put in negative x. In other words, let's evaluate f of negative x, which means this. Okay, and when you raise negative x to the third power, you get negative x to the third, and that produces this particular result. Well, as you can see, we have this situation. We input negative x, and we got the opposite of the function. So this is an example of when we're going to have an odd function. Inputting negative x created the opposite of the given function. Okay, let's try number 39. If we input negative x, then we're going to have negative x plus the absolute value of negative x. This is just negative x plus x. Okay, well, that does not give us the opposite function. And if we input negative x and we end up with the original function, then we're going to have an even function. Well, in this case, we don't have either one. If we input negative x, we don't have the opposite and we don't have the original. So for number 39, we're not going to have either. It's not going to be even or odd. Okay, let's try number 41. If we input negative x, it looks like this. All right, and when you simplify this denominator, negative x to the second power is x squared. Well, that's the original function. So this is the way it happens when you end up with an even function. Inputting negative x basically results in giving you the original function. Okay, let's do number 43. H of negative x. All right, this is what it looks like. Okay, so we have negative x to the third, and the opposite of that is x to the third. And then negative x squared is x squared, 3x squared minus 9. Well, what happened here is it's as though, we've talked about this before, we just put a minus sign in front, which changes either the numerator or the denominator. It won't change both. All it takes is to change either numerator or denominator to make this a negative fraction. So we have the opposite of what we started with in terms of sign. So that means for number 43, this is going to be an odd function. We're going to have origin symmetry. All right, so moving right along, we're almost done with this video. Find the absolute maximum or minimum. Well, what we're talking about here is either the highest point or the lowest point. And for number 45, let's just take a look at that one. We have an absolute maximum at this point, 1, 4. We're going to express it like this. At f of 1 equals 4, that's our absolute maximum. At f of 5 equals 1, that's going to be our absolute minimum. Okay, easy enough. Let's jump over here to number 47. On number 47, we have this minimum value down here, an absolute. It's a turning point. And then we have this maximum value up here. So the way we'll state our minimum, we have this minimum value, f of 1 equals 1. And our maximum is up here, f of 3 is equal to 4. That is going to be our absolute maximum. All right, so there's a couple of those examples. And then this will wrap it up. This example, we're finding the average rate of change. Okay, hopefully that rings a bell with you. That's just another way of saying finding the slope of a, when we used to talk about lines, it was finding the slope of a line. Well, this is a quadratic, it's a parabola, but there are some similarities. So the average rate of change in general is found in this way. Let's just take letter A as an example. To find average rate of change, it looks like this. We're going to do f of 2 minus f of 0. Notice where those numbers came from. I'm doing from 0 to 2. And we're going to divide that by 2 minus 0. All right, so let me see if I can squeeze that in here. Let's evaluate f of 2. It's like saying negative 2 times 2 squared plus 4. So 2 squared is 4. 4 times negative 2 is negative 8. And negative 8 plus 4 is negative 4. So f of 2 is negative 4. Now let's do f of 0. So that means input 0 into the function. And we get 4. So we're going to be subtracting f of 0, which is subtracting 4. And then this denominator is 2 minus 0, which is 2. So the rate of change for letter A, it's negative 8 divided by 2, which is negative 4. Okay. Letter B, same idea. You're going to do f of 3 minus f of 1 divided by 3 minus 1. Just like you learned earlier when you did the rate of change for a line. It's the delta y over delta x. The change in the y's, we're calling it f of 3 and f of 1, but same principle. Okay, so let's take a look at f of 3, see if we can do this mentally. 3 squared is 9. 9 times negative 2 is negative 18. Plus 4 is negative 14. Minus, now let's do f of 1. 1 squared times negative 2, that's negative 2. Plus 4, which is 2, all over 2. So we got negative 16 divided by 2, which is negative 8. And then finally, f of 4 is just repetitious here. F of 4 minus f of 1 divided by 4 minus 1. So f of 4 is 16 times negative 2, that's negative 32, plus 4, negative 28. And then we're going to be subtracting f of 1. Negative 2 plus 4 is positive 2. And then 4 minus 1 is 3. So this is going to be negative 30 divided by 3, which is negative 10. Okay, so that wraps up this section of notes for 3.3 to help you with the problems that we're going to be doing in this section. So let me know if I can help you.